Hello, everybody, and I hope you can all hear me clearly. Yeah. Hi, Kusai. Okay, so we can see people are still coming in, so we'll get started in a couple of minutes. Okay, I hope everyone has been in touch, like whoever signed up has got a login ID for the system. I mean, separate to the Zoom meeting, we do have, of course, we are going to have a hands-on part, and you will be using the system provided by Etisalat, and for that, you need to make sure that you have the login ID. So I hope everyone's got that. If you don't have the login ID, my colleague Neha is the co-host here, so do send her a message, and she will provide you with credentials to log into the system. We'll get into that later. First, of course, we are going to go over a few basics. And then, yeah, when we do the hands-on part, that's when you'd want to get in there. And again, any requests, please do feel free to contact Neha. She's the one who's going to be helping out behind the scenes while I'll be presenting from this side. So yeah, please do get in touch if there is anything that you want to clarify. Okay. So I guess we can get started. My name is Nikhil, and yeah, I will be conducting the session. We'll hopefully, it's a short-ish session. We're not going to do too much in depth this time. It's the holiday season, so we definitely don't want to go long today. And then, yeah, after that, we will definitely hopefully learn a little bit more about statistical control. Yeah. Okay. I think we're good to go. Other people will join in. We'll definitely just let them in there. Okay, I'm going to share my screen again so that we can continue. Where is my PowerPoint? Okay. I'm just going to remove my, I don't need to, there won't be any videos or anything. So yeah, so there we go. So, okay, so we're good to go. Let's get started with this. Okay, first thing before we get started on anything, let me just tell you a little bit more about the assembly. You would have seen the video at the start already, but I do want to convey a little bit more just in case some of you are not familiar with the concept. I will keep checking messages in between, but in case I don't reply straight away, please do message Neha. Because I'll be toggling between a few different screens. Okay, so just a little bit about the assembly. We are a smart lab and makerspace that's been based out of In5 in Dubai. In5 is, if you're not familiar with it, is the startup wing of Dubai Internet City, and they license and provide co-working space for a number of very smart startups over the years. We started in 2014, around the same time In5 started, so we have our own dedicated lab space there. We've been functioning continuously through there. During the pandemic, we've taken some of our workshops online, but our lab is still running, and hopefully soon we'll be taking our workshops back live as well. So we've done over 300 free workshops in the time since we started. The workshops relate to things like hack, which could be more to with IoT, but when we do them live, we also provide hardware. So we work with Raspberry Pis, Arduinos, and things like that, sensors. We'll use different use cases and embedded systems. So those are called assembly hack workshops. Assembly code workshops are those which don't require any separate hardware. I mean, obviously, you still need a computer, but we focus more on frameworks and apps and APIs. And of course, there are many workshops which are a hybrid of the two. The latest workshop stream that we've started is assembly data science, and that also sometimes overlaps with assembly code, where we try to focus more on advanced topics in AI and ML. Last time we did an IoT/ML session for this Etisalat workshop, and that was relating to the ThingWorx analytics tool itself, which allows you to do ML in ThingWorx, and we showed you how to do that. You can definitely see the previous workshops on our website, which is listed down there as well. Our audience ranges, I mean, we don't restrict our audience. We try to encourage students, professionals, entrepreneurs, Anyone who has an interest in smart technology and practical applications and use cases is welcome to join. Age is not a bar for that. So we joke around. Sometimes we say our age range is 6 to 60, and anyone is welcome to. And obviously now with remote sessions, you're welcome to join from anywhere in the world. All our sessions are always free. This is a community, not-for-profit effort, and we try to reach out to people just well, we're not a training center, but we try to give them an idea about different types of technology. We're very active on social media. You can find us as Make Smart Things. But you can also check out our YouTube video. This video is being broadcast to the internet also. I hope my internet is not okay. In case I do have any internet issues, if you have trouble following, please do message me on that. But I'll just keep on going like that. So yeah, so that's what I said. Like, our social media handles are there. You can also find us on YouTube. We upload all the videos and we live stream. This one is also live streaming to YouTube. And from YouTube, it's also being embedded on our site, theassembly.ae. You can find all our past workshops there as well, where we've gone into that. Those are all our workshops, not just the ones we've done with the Etisalat platform, but any workshops we've done, even related to open source and different types of topics. Okay. Just moving straight on. I'm going to get straight into what statistical process control is. I use that term, like, I mean, when we did the promos and everything, we use the term very organically, like, you know, it is something that people know about SPC, statistical process control. And what does it mean? So it just essentially means it's a statistical method of quality control for processes. So what does that mean? So it's part of like your quality control, you know, when you talk about quality management and quality control for processes, you do want to improve that quality all the ways. And this one does so using statistical methods. So I will explain this a bit more. That's just the dictionary definition. It's not a new topic. Statistical process control, SPC, has been there since since the 1920s. It's been developed in the US. I think it was Walter Schuchart who developed it, whose staff was the first. And there have been many different methods and many different rules and many different standards that have come up since then. If you've heard of Six Sigma, so people get a Six Sigma qualification. Six Sigma one of the parts of it is very important, is statistical process control. How to bring processes under control so they are not wasteful and so they are like functioning properly. And a lot of that is done. You can see the diagram that's just illustrated, but you can see how, you know, our values there have to be within some limits. So that is the ultimate goal in doing that. So our processes, of course, has to be driven by continuous data. So data has to come, and that is something that makes it especially useful when it comes to IoT, because IoT, you have, you know, oodles of data. You have tons of data that is continuously coming from sensors, their different properties, and data is not a problem with IoT. So primarily it's been used for manufacturing, SPC, to improve manufacturing processes. And that's still a case when you're doing smart manufacturing related to IoT. But IoT users can apply SPC methods even to supply chain. So you can optimize supply chain. You can do predictive maintenance. We showed you how to do predictive maintenance using analytics previously. But even SPC can provide a more basic level of predictive maintenance, so that you can look at your processes. You know, you could be in a service industry which has a continuously functioning sensor, and you could make sure that by using SPC techniques that you can ensure that things don't suddenly, you know, unexpectedly go down or unexpectedly like become inefficient. So there's a lot that can be done with SPC in a multiple number of fields. And that's what, thanks to IoT, we're not really restricted. So what is, how do we go about SPC? We can see here control charts are mentioned. Control charts are what we're going to focus on. There are many different techniques for SPC, but control charts are what we're going to focus on here, and they are the most common ones. So all of these, you can see the different examples of the charts. The main chart that you have, the simplest chart that you have, is something called an X-bar chart, which just maps the mean of the values. Now, we don't take every single individual value when it comes to SPC. We try to take buckets or samples. So we take maybe the last n number of values, and that n could be 5 values. And then we try to calculate a data point for those n values together. And these are all, of course, these have to be time series. So it has to be, the input has to be continuous data that is coming in a time series. What we do is, like, say if our bucket size is or sample size is 5, then the last 5 data points, and we group each of them by 5 data points, and we take the mean to represent 1 data point, which gives you the mean value, right? So each data point is a mean value over those sample size. So like we have X bar chart, so you can see X bar R chart of strength. If you look at the 2 images on the top, X bar R chart of strength and X bar R S chart of weight. So X bar R charts and X bar S charts refer to the bottom charts on there. The top bar is the X bar, and the lower part is the range chart. And this is the what's called as the sigma chart, or it could be the standard deviation chart. These are again statistical terms. What the range chart does is, rather than taking the mean of values in our sample, it takes the range of the values. So supposing our values vary from, say, 3 to 7. Yeah, and so if you got the average on there, it would be somewhere between 3 and 7. But the range is actually saying that 7 minus 3, the range is 4. So it would map out those ranges in each bucket, and that would give you a different chart. There are different bits of inferences we can make from a range chart that we can't make from an X bar chart, and vice versa. So we can set up rules that are separate for an X bar chart and separate for a range chart. A sigma chart is used when we want to do more, more with the data. Like, I'm sorry, when we have more of a sample size, when we've got a greater sample size, you turn to sigma chart, because sigma chart uses standard deviation instead of the range. So standard deviation, as those of you might be familiar with from the from any statistics you've studied, refers to a sort of variance. So both range and sigma match, and standard deviation document the variance in your data, and that's why they're both important. But sigma, standard deviation, is more useful when you have a larger sample size. And probably it's not always useful, but you do use it on there. Similar way on that. The document on the right, the image on the right shows you what happens. Like you can see most of the points, when they are within the range, within the the parameters are marked in blue, but the ones that are out of those are called out of control points. So those out of control points are marked in red in our graph. So those suggest that the process is not in control. So you want to, you can see that there the X bar chart has got points out of control. So that's one inference that we can make. Although the range chart is perfectly within range, we can still say, we can combine these factors to say that our process is out of control, if it is. Yeah, so we don't just base it on one particular bit of data. We try to take a few different, and it depends on what kind of parameters you set, and that's something that you constantly tweak. If you want more info, like I said, this is very important. If you're studying for Six Sigma qualification, the Six Sigma study guide actually has some great notes on that. I will also share. So if you'd like to see, I'll actually just put this in chat. If you want to see the this same presentation in PDF format, so I'm just typing that out, and you can just get that. I think it's called. Sorry, excuse me for a second. Yeah, it's just called spc.pdf. Yeah, that's it. So I mean, it's the same URL as our as I mentioned, it's the same URL that we use for the online server. So if you just add / and get spc.pdf, you'll get this, and you can see all the links from there. So this presentation is there. So you can just get details from there. So that's about control charts. In this session, we are going to focus on control charts because that's there, but there are many other methods, and there are many other Pareto charts are there. There are different types of methods, but we will just focus on control charts as the primary method of SPC control. Control rules are important. Like, there are different parameters for there. So we've seen how to map out the data. Control rules tell us how we can classify any data that is any data point to say that it is outside of that. It's not enough to just visually say that it's outside there. We want to mathematically qualify it. We should be able to visually also identify it. We are going to use, like the example we're going to use is going to use something called Western electric rules. And I've given the Wikipedia thing there, which is quite detailed. It does some, gives a lot of details about that. But we're going to focus on the main thing, that we're going to focus on the subset of Western electric rules. We're going to look at zone rules. So zone rules are apparent from the X bar chart. So if you look at this, you can see there are 3 zones based on your standard deviations. So there's a center line. The center line is the black line, the solid line, which is where the value should be. The center line has 3 zones around it. Zone C is the innermost, where it's up to 1 standard deviation plus or minus away from the center line. Okay, so if your data point comes in zone C, that means it's within 1 standard deviation and close to our center line. Zone B is the part where it is 2 sigma, 2 standard deviations away, and zone A is where it is 3 sigma or 3 standard deviations away from there. Okay, I'm not going to get into this in too much detail. We're just going to focus on the zone rules because that is what we'll be implementing in our engine. So if you look at the different rules that are there, these are the 4 basic rules that are used. So rule 1 means that any point that goes above the zone A, which means it's more than 3 standard deviations away from the center, it will be flagged as an out of control point, an OOC point. Okay. Similarly, if you have two out of 3 consecutive points that don't go beyond zone A, but they still fall in zone A or beyond, right? So if consecutive points are there, that if they fall in zone A or beyond, that will also flag up an error. I mean, not an error, it will flag up something, an OOC. Rule 3 means that if 4 out of 5 consecutive points fall in zone B or beyond, so not necessarily all the way to zone A, but zone B, then it flags it. It says the next one is marked as red. It says it's already got something. So you can see in rule 2 and rule 3, the red point is the point after the 2 consecutive points that have gone outside. So you can see 2 consecutive points are there, which are in zone A. So the next one gets flagged as a red point, as an OOC. Similarly here, say, with this, you can see 4, you can see here that there are 4 points which are in zone B, 4 consecutive, so it marks the next one. So there are a lot of these rules, and you can define your own rules, and you can use different systems that are there. This is just one system, and these are all well documented, and how they do the calculations, how they calculate, the lines, and what the UCL is, LCL is. All these there are some constants that are used, and our engine will be just using constants that are based on this Western electric rules. Read the Wikipedia page. There are a lot more details. It talks about stratification. If too much data is concentrated in, say, around the point. The last rule is also important here, where we say, the 9 consecutive points are on the same side of the center line. Why is this a problem? It's because that means that all the data is being skewed on the same side. So you would expect data to skew on either side of the line, but in this case, it's skewing all on one side. So we say that there's some error. So this is just an example of rules. And these are rules based on the X bar chart, but the R chart and S chart also have their own rules, but they're slightly different. And you can see that in the Wikipedia link. So these are just control rules that you can get from control chart. Okay. This other part of this is where we talk about process capability. Again, there's a Wikipedia link there that will tell you a lot more about it. What process capability means is how capable your process is. So you want your process to be capable. It tries to get a metric where you can say your process is capable based on that. So it compares, and with process capability, unlike those, you do have to give it some specs, and we'll be incorporating process capability, and we'll be giving some specs. We'll be saying the upper design spec and the lower design spec, and it compares an in-control process, which is a good process, an in-control process, to the specs and saying whether it's capable. Okay. Mathematically, there are 2 indices that we go with. There's something called CP and CPK, right? And you can read that. Those are the process capability indexes. There's a separate wiki link for that as well. So CP and CPK are the only 2 that we are focusing on, but there are multiple. So if you see that I've put in the mathematical equation, so CP is basically the upper service limit minus the lower service limit, which and just divide it by 6 times the standard deviation value, right? So that is how it calculates. So in our software, we will be calculating CP and CPK automatically, right? CPK, the difference between CP and CPK is that CPK actually uses the min function. So it tries to centralize your data. Now, what does that mean? There's a good analogy that you have with the cars here. So if you see a car under A will have a CPK, because it's perfectly centered, it fits your garage. So your car fits your garage perfectly. Well, you would say that's probably a CPK of 1, right? Which is good. The second example in B is a CPK less than 1, which is a non-capable process. So if it's greater than 1, your CPK, that means that your process is capable. That's important to say again. It's not capable because your car is too big for the garage, and that means that's a non-capable process. But the difference between CP and CPK comes in C and D. So in C, you see that is still a capable process because your car fits in the garage, but in C, it's not centered, and the CPK there therefore will be lower, whereas then in D, where it is perfectly centered, which means the data is centralized. So the same way in your spread of values, you can think of it as even as a dartboard is another analogy that you make. If you have a central point and everything is proper, will be the same. But if your center, if it's evenly distributed, but it's not close to a center point, that would mean that your CP will be high, but your CPK might be a little lower. So that's where the distinction comes in there. Another common way of displaying capability is from the capability histogram, which maps all the points and sees where they fit. So a histogram just gives you a spread of points. So you can see the actual process spread. And as long as it does not go outside the 2 limits, it is likely a capable process. So here a histogram says like, okay, obviously the distribution is maximum towards the center, but you have all the points in the histogram are within the range. So it is a capable process. These are topics that come into statistics. So I'm just doing a very quick refresher on that. I definitely urge you, if you are planning to do anything related to this, you should check it up and see what you can do with this. So let's go into the next one. So we are going to use the ThingWorx SPC accelerator. So previously we've used, things from, we built our own solutions in ThingWorx. Here, what we've chosen to do is we are going to use a pre-built full solution that comes from ThingWorx for the purposes of SPC. And, when I say a full built solution, it's not just one web page. There are underlying things. Things, as we've defined, are what model real-world data on the cloud. Mashups are what we call these web pages, and there are mashups already contained within. But we will look under the hood. Projects such as groupings, they're just logical groupings. So you don't have. So I will be showing you that in a bit. Now, the example here is the main one. So you can see here, there are multiple streaming assets here. And these are the same ones that we're using. And each streaming asset is for one property. So we can add multiple production lines, and I'll show you how to configure that later. So we can add line 100 here is our production line. And under that, we have the asset, which is there is motor blower 1 and motor pump 1. So we're just assuming we'll be using the same assets, by the way, motor blower 1 and motor pump 1. And the properties, they have different properties. So motor blower 1 has different properties where the data is coming in. So it has 2 values for pressure, 2 values for temperature. And motor pump has 2 values for vibration and 2 values for pressure also. And we will specify, so then you can get like an SPC display here. So you can see all the ones that are marked in red, and you can't see the one that's highlighted, but that also has an out of control rule. It says the range chart. If you look at the range chart, which is the R chart below, it's got 1 red point. So it says range out of control. So in one of those, again, this is like a timing, time-based graph. Although if you see the XBAR chart, the mean values are all within the range. So there's no warning from here. The range chart gives us 1 warning from a few points before. This is the capability chart. There's a capability histogram, and you can see it's within the range there. The set point is at the center, and this histogram is, it's mapped, it's all around this thing. So this is just an example. This is what we will be working with hands-on. I'm just going to, let me just get into that. So before we get on to the hands-on part, most of you would have seen this, this particular slide before. there is a little bit of online cloud access etiquette because we are using the same sandbox. The link, as always, is thingworx-serve.theassembly.ae, right? And you can use that. All of you have been sent login details. If you haven't, please message Neha, and you will be given a username and password. If you've already done it before, then you will have like one that you can use again and again, even for the next few workshops. But if you're just getting one now, we'll just provide you the temporary password that you can use for this session. But yeah, you should register for the next session, and you get access directly. One thing you have to do is like, okay, we are using just a sandbox. You should prefix and suffix any things and models you create with a unique identifier. So my initials are NS, so I will just I'll add _NS to the end of all things I create. If you try to overwrite a thing, it will it'll either lock it or it will just overwrite. So I urge you not to do that. So please don't edit or modify objects that are created by others. Obviously we'll work on an honor system here. So this is just sandbox data, just dummy data. So we're not really in the production scenario. You could lock down a lot and you could set permissions, but we're not bothered about that here. While logins will persist beyond the session, don't count on the data persisting. So if you've created data, every once in a while, I am going to refresh the data. If there is any data that you want to preserve while you're working, and we strongly urge you to keep working on this even after the session, because you will have access to the server continuously, but the data might be, we might move it around. So if you have any data, you have export and import rights, so you can export the data into, XML files or TWX files. So feel free to do that. So this is just a few rules of the etiquette. The link, okay. So there is some data that you can download. Again, this is also on ThingWorx-serve.theassembly.ae. The other one was spc.pdf. This is spc workshop data.zip. So just download that. It's not too big a file. This has been curated from developer.thingworx.com, and you can get a lot of details in on that. So just download that. I'm just going to, so if you get a chance, I hope everyone is, I don't think you'll see this if I open it up in a new window. Okay. So yeah, so I think that should be enough time. Everyone would have seen that. Just going to type it out here in the chat. slv.theassembly.ae/spc workshop data.zip. So in case you haven't seen that, I just shared it here. And yeah, like I said, the link, and I will be just getting onto that, is theassembly.ae. So that is where the online server is, but do get the data. Okay, I'm just going to open up my data and then I will share that. So that's the extent of my slides. So don't worry, it's not going to be death by PowerPoint. But I just wanted to cover some basics because these are going to come up when we actually discuss things. Sorry, just give me 1 second. I'm just opening up my. Yeah, okay. Okay, just going to share. Let me see if I can just share my, just to give you an idea. Okay, this is the folder that we've got here, right? So you can see the files that are there. So there are two files, like once you download SPC workshop data.zip, it'll contain 4 files there, okay? You are not going to need the first 2. I've just provided those. These are actually the SPC accelerator, ThingWorx SPC accelerator. All the files that you need to import are all contained in this. So if you recreate on a local server, and you want to use the SPC accelerator, this is what you would use. But I've just included those, but you don't need them here. I will be uploading them to the server myself. The other two files, the two XML files, are template files. One is a template for motor blower 1 and motor pump 1. Okay, so just keep those somewhere and I'll show you how to use them. You don't have to use them, but you can use them. I'll explain to you how we're going about that. Okay, let me just open up my composer. Okay. And let me just share my screen before I do that. Okay, I hope everyone can see my screen now. I'm just logging in. So like I said, it will redirect you to ThingWorx and you will get, I'm going to be logging in as admin. You will obviously be under different users. So it will give you a message at the start because it redirects to an IP address. Don't worry about that. It's just a certificate error that comes up. So if it says, is it safe to, you can go ahead and do that. There is no risk involved with that. So once you do that, you should get the same window that I do. After you entered your username password in the pop-up, and you would have. So we've used this many times before. Okay, so this is the ThingWorx cloud system, and this is where we're going to be doing all the work that we've done. So I need to import two files here. So what I'm going to do is like those two files that we've kept, the SPC. If you look at, like, as always, you can see, like, all your different, there are things, there are projects, there are thing templates, and right now there's nothing much on there. I'm going to import the data I need for relating to the SPC accelerator. Okay. So there are two files. First, I'm going to import, oops, where is this? Yeah. Okay. So I've got, where have I kept the data? Yep. So it's there. Okay. So what I need to do from here is I'm going to go into the data folder. So these are the files that we had before. And I need to first download PTC_statistical. You don't have to do this. I'll just repeat that because this is all just has to be done once on the server and you will have access to all the things there. So just do that. And then I say import. Once I do that, if I go and refresh here, I can go to my project view and I can just add the project that I want to see. And you can do the same. You can just, like, this PTC statistical calculations. So this is just a small project. It just got a few things, shapes and projects, but I'll also import the other one that's there. Okay. Once I do that, I come back to project view and I'll just open up that one. That is ptc.spc_pj. That is a much bigger project and it's got a lot of different things. It's got 7 things, 1 template, 17 data shapes, 3 mashups, lots of things, and things that we won't really go into also. The main files that we want to see, and I'll show you this later on, the main work that's done is the most significant things that we've got in this one are under things. So we've got motor pump 1, motor blower 1. Those are the 2 things that are going to simulate our edge devices that are sending data. We've got we've got some, like, worker things also that, like, do the work and, like, have lots of services on that. I think that is like PTC SPC configuration helper. We'll take a look at that later. I'm going to come back to this. And we've got two mashups that are important. One is there's a configuration mashup and there's a monitoring mashup. And so their system is like they've put _mu with that. Okay, so right now you don't need to import anything, so just have a look. Let's start first off with this PTC statistical calculations thing. And like, again, project view is great. It's a new thing since the last year or so, and it gives you you know, a good logical view of things rather than just going to browse and seeing everything all together. So there are only like definitions here. Now this is important. I just want to remind you of something. So there are thing shapes and data shapes are two separate things. Thing shapes are templates for things, which are like, you know, the models of real world objects. So in our case, like I said, we've got motor pump and motor blower. So, or if we had, like, say, we had an edge device, when we want to model them on ThingWorx, we model them as things. Okay. But thing shapes are there to provide a templatized way to do that. So in case we have, like when we did the vehicle tracking one, a vehicle would be a thing shape, or you know, it would just implement all the things, and then the thing will be derived from that. It's very similar to object-oriented programming, as we said in the past. So thing shapes provide a base template, and then rather than creating all the properties and all the behaviors and all again and again for objects which are similar. So in that case, like we might have like 15 cars in our, and we, you know, we don't want to necessarily create a new thing from scratch 15 times. We would define everything in thing shapes and we derive from the thing shape. And then of course we could also customize it at the end. But thing shape provides a template. And if we look at this one, this has got a thing shape here, you know, which is just used like a thing shape, like a normal thing has properties and alerts, it has services, it has subscriptions. Here, there are no properties defined because this one has just got services really. So this is where they define a lot of the services that we will be using for, and, you know, this will be derived in our things. And like, well, you know, when the things that will be created on the fly. So there are some things that will be created programmatically by, you know, by our solution. They will be deriving from here and they will already contain this code. So you can see the code also, like, for example, these are all statistical methods that are contained there. They're all in JavaScript. So this one, for example, calculates bin data distribution. So it does all the mathematical functions and then returns an info table. An info table is just a table, right? Like a regular table. It's just a set of records. So you have like any table that you have in any programming language. So an info table just has, you know, it has record headers and then it's got rows with values for each of those. So this is one function. They're all in JavaScript. So you can see the input, it takes a set of timed values and it transforms it and gives info tables out. So it will take the timed values here, which are just like the set of your raw data, and transform them. And there are many different functions here like that. If you look at, there are other ones also. There's a lot of, you know, statistical ones. These ones just return number results. So they just return one value. This one is a Boolean. This one is, you know, it gets a number. So these are all statistical methods. We don't really need to worry about them. These are just putting these in here so that they can be used directly rather than say, there's nothing under events, I think nothing under subscriptions also. So it's just really a wrapper for services. So all the JavaScript we put into here in different functions, and then these functions can be invoked eventually by the mashup through a few different levels. And I'll show you the levels also later. So that's a thing shape. I'm hitting cancel because I don't want to modify it. The data shapes are different. Okay, somebody is modifying that. I urge you not to modify these because they are on there. So because you don't know what, you might break the system somehow. So please do not. It's not permitting me to edit that. I think I had opened it up previously, so it doesn't matter. Don't worry about it. I'm not planning to modify it. Data shapes are different from thing shapes because data shapes provide the template for info tables. So info tables, remember I said, are just tables of records and they have field headings. So field definitions are put in here. And these are things that are used, in fact, by the helper. So if you look at the, you know, all this is just a field definition where it says, so this is, it says a bin, which is just a collection. It has a min and a max and a count of how many items it is. All that is just encapsulated in here. So this is one data shape. Another data shape that we have here are timed values. Remember, we said timed values are the inputs there to functions. All the timed values do is just has a timestamp and a value. So we get values from the edge and they're put in here, and that we get the timestamp and it fills it in. This is just providing a structure in which it goes into the info table. So there's not much we have to actually see here. So this project is more like a helper project. So we don't really need to look at that. So I'm just going to close this off for now. So, but it is important in general to understand the difference between thing shapes and data shapes. In fact, I'm just going to remove it from the project. We will just go with this. Now, if you look at it here, right, let's look through the things. Like I said, the two most important things we have here are motor pump and motor blower. They are almost identical, but they are simulating our data flow from the edge. Okay, so we're assuming like in real life, this data would be synced up with an edge device thing, and the data would be continuously flowing through our two-way connection. But in this case, we're just going to simulate. And for doing that, both motor pump 1 and motor blower 1 are derived from timer. Okay. Again, please don't modify any of these. We're just going to be using these. So motor pump 1 and motor blower 1 derive from timer. Timer is just a base object. It's a base thing template which just triggers an event every n seconds. So you can see there is like, and we've used it in the past in different workshops. So it's got an update rate. So that means every 1,000 milliseconds, this thing will send out an event. Okay, and we can capture that event in a subscription. And what that does is, so subscriptions are like, so it's got an event timer which captures every time the timer, which is part of the base thing, the base template, clicks here, it just calls a function. It calls a service called simulate values. That's all it does. So every 10 seconds, it will be calling this value called simulate values. Now, what does simulate values do? For that, we go into the services. Okay, before I go into services, let me just show you the properties and alerts. Like I said, the properties and alerts, the ones that are crucial here, and you can see they're actually running because the timer is working. So if you hit refresh, the values of pressure 100, pressure 200, vibration 10, and vibration 11 are changing, right? And that is being done by that value, that service called simulate values. How is it doing that? So it is using something. So there is an info table here called data. So if you look at data, open the wrong thing. If you look at data, and if you just click edit, you don't actually want to edit, but it'll show you the data there. So it'll show you these are values. So they've pre-populated, and this is got from a comma separated list. They've pre-populated 1,000 rows here, and all simulate values does is keep alternating between this. So it increases the counter. It increases the counter, the current row, and the index. It keeps changing. And as it's changing with the time sector, it's getting the value in that particular row in the info table and filling it in here. So you can see that the services are there. You can ignore the copy data. The key one is, again, simulate values. These are just JavaScript functions. All it does is it goes through the data table, and again, it returns, well, it returns nothing because all it's doing is modifying the property values. It's updating the property values from the values in that row. So the corresponding row, it checks the row based on, these are just like, if it says the current row is there, if current row has gone past, then it will reset. So it just keeps taking different rows and filling values. So that way you get some streaming data, and it simulates the streaming data. Very similar to this. Motor blower 1 also has exactly the same. It's derived from timer. It's got the same services, and it's got the same subscription. And again, the values are being updated here the same way. So every 10 seconds, these values will change. So we are getting some streaming data here. So this is really important to see there. The other thing I wanted to show you is, okay, where does this derive from? Okay, this is something we might use later, the TT template. Okay, the TT template, again, it's being, okay, but you can ignore that, please. So the TT template is another template that will be used on the fly. So remember I said there are thing shapes and there are thing templates. So thing templates can be used to instantiate things programmatically. So right now here, you can create things and you can do stuff with that. Like I can create things manually here, or I can go here and I can create things. I've done that in the past. But there is also using the API, there is a way to create things dynamically, but all things need a template. So rather than say defining all the properties at once, we can give it a template. So this one is used to create things on the fly. It's got a certain set of properties, a lot of statistical parts. You can take a look at that. I'll explain this to you more when we actually instantiate. So, but just keep an eye on that. This is a thing template that's used. It's got services, it's got properties, so which will be used later on that, but you can ignore that for now. Anyhow, we won't go too much into this. You can definitely explore this more later on. Okay, just coming back to that. Now, one thing I want to point out to this. So when we actually use this with the SPC, you can only use your one instance. It'll be doing that. If you want to use another version of motor blower, there is a function here called duplicate, but that will not copy the table and the values. So if you want to do that, remember the two files I showed you earlier? If you go to import, what I do is, okay, let me just go back and share that table again. Sorry, I'm going to do a new share. Okay, so this is just, by the way, don't get alarmed by this. This is just my version, my dual window on this. So remember the data you downloaded, right? Like there were two XML files, and these are things. These are actually the actual like things which I've exported. So I exported motor pump 1 and motor blower 1. Now, if you want to use your own, you have to give it a different name from motor pump 1 and motor blower 1. So what you do in that is you just have to open up the XML, look for motor pump 1. It'll just be there in one place. That's the name, and I've actually given it a suffix of 00. Just change that with your initials. So edit this in text, just change these initials and then import it. Okay. So in this case, for example, I've got 00, right? Now, if I go there and I come back to my program and I come and import this. So say if I go to motor blower 1, because I've added 00, it's not just. And then if I just go here and I refresh the view, so you can see there's another thing called motor blower 1 _00. So the same way, if you want to use your own things, you can take those two and just import them with different underscore. They will be pre-populated with all the data, and they will also be doing like all the same functionalities there because they derived from timers. So you can do that. But for now, I'm just going to delete this. But you can do that same thing, but be sure to edit the name in the XML file when you do that. Yeah. If you just want to follow along, you won't need that, but we'll just definitely look at that. So I've shown you everything on that. The simulate. One more thing I wanted to show you under services. So if you look at simulate values, we did see that where it adds the row, you can see it also adds. So we get the data as the basic row, right? Remember the row are the pressure values, the time values, but it also adds a time rating, which is the timestamp, the current time. So this is how we transform these into timed values rather than say on the, directly where we need this. So our info table will be there, and there's a quality also given. So quality could be, so it's a VTK value time quality. So the simulate values shows that. So we've understood how motor blower and motor pump work. Now let's see how they factor into that. Okay. So now let's go straight into, like I said, let's go into our mashups. Okay. And I will come back to, like I said, the function that we want to see is this configuration helper. So let's go into our mashups. Okay. The first mashup, I'll show you the functioning of the mashup first, and then we will look under the hood for it. Let's go first into, there is a configuration mashup. So, okay, I'm not going to be editing it, so it doesn't matter even if it's read only. So like we've done many times in the past, the mashup is a web application, and it wraps around the things, it invokes data from the things, and this is the mashup builder. So I'm just going to increase the size so you can see. So see the canvas in the mashup. So this part below, as we've seen before, and this part on the right, this is how we bind data from things. So it binds from, like we said, configuration helper is a file that has a lot of different functions. That is how, all the data that we have here gets mashed up, so this is where we define our items. So we've got list items, we are, so this is the thing. So we don't need to worry about this. Configuration mashup is just like, what we need to do is just click on view mashup from here. You don't need to edit it. View mashup shows it to you as a web page. And this is the running. So when we want to use the SPC accelerator, this is what we do. So right now our SPC accelerator is blank because we've not created anything. So the hierarchy that we want to do is we want to create lines with multiple assets and assets with multiple properties. Okay. But our first stop is that we want to add a new line, and all of you can use the same line. If you can just follow along with what I'm doing, but you can also invoke this. But if you do, please do create a different one. So I'm going to call it assembly line _ns, right? So this line, by the way, is not a thing. It's not being created as a thing. It's just being created as in a data table, the data. So it's not creating a separate thing. Once we do this, you notice, of course, that bottom thing is gone because right now the line has been selected. And until we create an asset or until we select an asset, it will not show up the property configuration. Once we have this, we've created a line. It's created in the line assembly will be created in some table somewhere in ThingWorx. You don't need to worry about that. We need to select an asset thing from the things that we already have. So remember, the two asset things we have are motor pump, and it's got autocomplete, so you can just select from here. Now, here's where you have to be careful, okay? So there is going to be some programmatic work. If you select motor pump 1, it will again be generating the same things for the same settings. Okay, so you have to be a bit careful. I'll explain what happens later. But I'm only going to use, in this case, just motor pump 1, right? So let's go straight ahead with motor pump 1. And I say we add assets for this line, and there it adds the hierarchy there. So you can see that. Once I select the asset in the hierarchy line, it shows up the properties are eligible. This gets the properties all in the thing. And like we said, pressure 200, so vibration 10, vibration 11 is what we want. So I'm going to do actually one thing. You can also delete from here. If you want to just, there is a way to, so you can just select and go to remove selected. I'm actually going to, instead of this, use the other asset, which is motor blower, right? I'm going to add the asset for the line. Now it's there, and you can see different properties there. So this is getting from the underlying thing that works with that. So what I want to do is I want to get data for each. I want to set up each of these properties. So each property would have one, like one set of charts. Okay. So what I'm going to do is I'm going to set up for pressure 1. I'm going to go into sample size. I'm going to keep the sample size and the X bar points. So what this means is sample size is how many, remember we were talking about the samples for the charts. So I'm going to say that 5 data points from the motor blower, 5 points of pressure are going to be grouped together as one data point in our charts. X bar points says, I want 30 points there. So 5 into 30 is the number of total underlying data points that need to be generated. So all that data that we saw that is going on being updated is going into there. Okay, that will not start being generated until we create this. So after you do this, you need to let it run for some time before you actually view. So 5 into 30, we need 150 points that are generated. So which might take, if it's say it's like 10 seconds or whatever, it will be going in on that. We'll keep capability points the same. The set point we're going to change, because I will take a look at the values. I'm going to set the set point, which is the center line, as 73. This is for calculating our capability. Okay, the set point, lower design spec and upper design spec come into the play for the capability, which we saw, the capability chart. In this case, I'll just set it to 68 and 78 is my upper design spec. So our capability chart will be showing those two lines and the center point there. So I can select between an R chart, which is a range chart, and a sigma chart, as we talked about. I'm not going to go for an S chart. If I toggle, it'll be taking the R chart here. So I'm just going to take this and add update SPC monitoring, and then you will see it shows up here. When it shows up here, I can modify here and do that. If I want to see the other ones, if I go back and select the asset, I can see the other ones, and I'm going to add all of these, like pressure 1 and pressure 2. I'm just trying to take a look at what the spec should be. Yeah, so for pressure 2, I will just go with Again, I'll just modify this quickly. I've got a chart where I'm just doing that. So I'm doing a little bit of a cheat there. Oh, sorry. Again, I should do 68 and I should do 68 here. Sorry, that's the wrong one. It should be 78. 78 and lower design spec is 68 and my upper design spec is 89. So this one, again, for pressure, so I will just add an R chart only. And I come back here to the motor blower, temperature 1. What should I do for this? Okay, temperature 1. Okay, the values are a little lower because temperature, obviously. My set point is 50. 44. You can always come back and edit this here in the configurator. So you can come back here and edit this, but it will restart the process. So if your data has already been accumulating, it will get restarted in this. Okay, so I've just set it to 56. And now instead of an R chart here, I will use an S chart. So for the temperature values, I'll use an S chart just for variance. It's not really a need on there. So I come back here. And I'm not going to bother. I could possibly go and show both of these, even the other one, but I'm only going to show you for blower. You feel free to play around with the motor pump if you want to do that. The set point here should be, it's higher temperature, so I'll go with 85. And this is 73 and 97. And here again, I will take an X bar chart. One thing I will change, 30, 60 is fine. Yeah, so I'll just keep that. The capability points, by the way, I didn't mention that. Capability points is how many points it uses for the capability chart. So X bar points is how many points it uses for the X bar chart, and capability points is how many points it uses for that. So that's how many points. The total number of underlying data points would be 16 to 5 and 13 to 5. Okay, so I'm going to add this, and with this, all my properties are done. So I'm done with the configurator. I don't need to come back to this. I'm just going to leave it like this. I'm going to come back here to my to this part. I'm going to close this off. So if you see, everything has been instantiated from here. Even the properties that come, they come from list items. It gets from underlying things, so it derives from there. Like I said, configuration helper is where it gets a lot of the data from. Configuration helper wraps around. So if you go to, you can, and again, we don't have time to go into this in detail, but configuration helper is like a helper function that adds a lot of properties. These are accessible directly by the mashup. So the mashup calls configuration helper functions, but configuration helper functions, like the main function that you need is get SPC history. If you look into the function there, it's just getting it from the, it's getting an info table, and it is just getting it from the specific thing and just getting the history there. Now, after I've used the configurator, you're going to notice something interesting has happened. If you go back to your browse and you look at the list of things, there have been the system has programmatically created a few new things called SPC underscore, this will always be the format, SPC underscore thing name underscore property. And if we open up one of these, so for pressure, for example, so remember I said the base thing template is SPC underscore TT, so it just uses all the services. So if you see the services that we were talking about have all been inherited here. So calculate maximum value, calculate mean value, all has been inherited, and they are available to this particular thing that has been directly created. The properties, it just creates, and you can see the properties are being filled up here. It's taking values from the underlying and all of these. The difference between this and the motor blower is that is running on a timer. This one has a value stream. A value stream is what stores historic values. So based on time, and we've used this many times in the past. So it will be using the time-based values. So even though your source property that it's filling is changing, the past values are getting stored in the database. So there is access to that, and we can access those, and that is necessary for charts because we need to access past values. But a few other things have been stored here. So you can see these also changing. Some of the values are being stored. We've set the set point, it stores here. This is why I said, if you do add another line item and you add motor blower again, it will overwrite this thing. It will create a new thing and it will overwrite, and it will use the latest properties. So it will overwrite that. So it will cause a bit of mayhem on that. Anyhow, that's what I wanted to show you, that if you that these are programmatically created things. that have been created by the system, automatically, one for each property that is being monitored. Okay, and these values are being generated, and there are different things. In fact, you can even see. So there's an inherited property that it does, that is called, it calculates the SP properties. So this is running again just whenever the source property. So this is how we've set this before. This subscription is not to a timer property, it's to a data change property. So whenever the source property changes, so whenever this value changes, it calls a subscription and it runs, it populates some other data in a table. All this is being stored. So all of this is being triggered automatically. So these values are there. So that's why you'll see certain other values which are going to be used later on by this. So configuration helper calls these things and gets the values from there. So it gets all the SPC properties from here. I'm not going into detail with like what's under the hood. You can definitely look at that, but it'll be beyond the scope. So since we have to go a bit faster. So now once we do this, let's take a look at our other mashup, which is under this one, SPC. So you'll notice this one also gets created in the PTC default project, not this. So they've not set that. So that's something in the code. You can ignore this. Okay, this is, I'm going to go back to the project view. So under project view, now we look at, like we've already seen the configuration mashup. Let's look at the monitoring mashup, which is actually what we showed you, what I showed you before, the screenshot of. The monitoring mashup is where all the the good stuff happens. So before I show you that, I'm just going to give you a little bit of info again about what the monitoring mashup. So you can see it has a line of all the items here. This data is bound. Just going to minimize this a bit so you can see a little bit more. So you can see the data is bound to underlying things. It gets all the data from SPC configuration helper, which individually then calls programs to do that. This is how the charts are populated. So each of the charts has data bound, and you can look at like, these are the functions that it calls. So all of it comes from SPC configuration helper. So it gets the SPC history for the selected thing dynamically through SPC configuration helper. So SPC configuration helper is a thing that goes and locates the thing that is being selected and gets it dynamically. It gets a capability histogram. These are all functions that are contained there, and then it binds it separately to different charts. Okay, so you don't need to worry about this too much. We should just look at what the mashup actually does. Same way we view mashup. And again, for your end users, you can also set these mashups so that they see it on login. So they don't, if you don't want them to have access to Composer, you can just directly do this, in this way. So I'm just going to go back to the motor blower, for example. So as it happens, we have enough data that's being populated here. So enough data is being populated that it keeps on, that our charts are showing up. Now, if we come back here, so you can see this. Now, what does this chart tell us? Like, it tells us, like, when we select each of these individually, it changes the charts. All the charts that have blue mean they have no out of control for rules. So none of the rules have been violated by the points. So if you look at this, all the points are within. There are no consecutive points that are coming over and above. And the one that is red has an out of control rule. Now, if we select that, so that's temperature 1. It says 1 point is outside control limit. So it's flagged that and it's modified this. All of these are coming from different services in there. The CPK value is also there. The capability is quite high, actually. 2 is very high. Any capability that's above 1 is considered a capable process. And you can see that demonstrated on the chart also. So if you see the chart, this is the lower spec, that lower design spec that we specified in the properties in the upper design spec, and it's well within that, right? It is actually within 3 sigma, itself. So it is actually well within. So the histogram has no problem. However, the XBAR chart, like I said, the 1 point has gone outside. So it says your process has gone out of control. But otherwise, these are just the values. And remember, these are not the actual raw data values. These are for our sample size of 5. So what it does is the last 5 values are averaged into this point. The last 5 values before that average into this point and this point. So these are all grouped by 5. Similarly, the S chart takes the STD standard deviation. The X bar here, by the way, is just this middle line. which is the dashed line, which is just the value. It's just an average of the averages. So it just takes an overall average and just plots a line there. It also plots, for our sake, like 3 sigma limits so that we can see above the different zones are also. So this is our zone C, our zone B, and our zone A based on the sigma limits. And we can see that 1 point has gone outside even zone A. So it has flagged the rule here. Similarly, but our range chart is well within our rules, so we don't have to worry about it. Range charts usually have rules that correspond to, how the process is. Like it should be, the range should go up and down. It should keep varying. It shouldn't be too out with there. So, but I'm not going to go into detail for that for sigma and range. There's a lot we can see with that. Let's just look at the rules that we did with the zone. The capability, as I mentioned, is high. The chart is there. Similarly, if you look at all the values, all their capabilities are good. The pressure, like they are slightly different. CPK and CP is slightly different, but they're more or less the same, which implies they're centered. So that's the thing. Now, again, this value is like right now we are just using static data. So if you'll see, although the time has gone on to 6:35, it is still showing data from 6:30 to 6:32. Okay, this set of charts only corresponds to this many points. So there are 50 points here that have been, so 60 points that if you count totally, the number of points, like I said, these are buckets. Each point represents 5 data points, but there are 30 points here. And it's only for the timestamp at the time I started. How do I get to see more time things? I just click refresh now. When I click refresh now, it'll move it up. So you can see it's now moved on to the current time, 6:36 and 6:33. Now you can see the values change a bit there. And again, some of those which previously violated out of control rules, now, for example, temperature has no out of control rules. It's fine there. So we can set this in such a way that, okay, you can refresh manually if you like, but you can also, there's a small toggle next to that. If you set that on, it is set like that is actually a toggle we've used. It will refresh every 10 to 30. I think it's set to 10 seconds or 30. No, sorry, it's set to 30 seconds. So every 30 seconds, it will automatically update and it will replace the thing. So you can see here now we've got a law, we've got an out of control rule here. And this one, like the pressure one, is there and it just refreshed. So it shows you that the pressure, it says 8 consecutive points above center line, which we can see the consecutive points are above center line. That's why it's flagged it. Okay, I think it's just duplicated. So that might be a problem in the code in the refresh. But even this one, we can see 1 point outside control limit, but that might change as that gets aged out. So every 30 seconds, because we've set the toggle on, you can see that it refreshes. So now temperature 1 also says the STD, the standard deviation, has got a point out of control. So everything changes according to time. So you can set this off and you can manually refresh whenever you want. Again, if you hit refresh on your browser also, it would show you, with the latest time limit. But if you don't want to refresh your full browser and everything, you can just do refresh. The other good thing about this is they've also set, by the way, if you want to see the charts in big mode and you don't want to see the properties, if you want to just select one property, you can minimize this. They've made it a minimizable template. So then this is just going to show. But when you do that, obviously, you should probably set the date on. You can also, it's also got a date and time picker. So right now, this is for the current time, but I'm going to set it for just like, say a few minutes before. And then if I want to view the data again, and again, if you have a lot of data accruing over many days, it'll automatically be putting that, right? So if I do this, now it goes back to what the time was at 6:32, it's kind of kept it there and it says 6:33 and it shows me the data that was then. So it is pulling all the data. And as this goes on, this can go running for hours and days and you can keep on seeing all the values. And then you can analyze your data and you can see where the points are out and where the process is out of control. So it's a very easy way to customize a lot. So you can do the same thing there. And like I said, I've shown you all the basics. This is all I wanted to really show you on this. So this is the SPC accelerator. You have access to this. You can feel free to try. Like I said, you can duplicate the objects and try to add your own, go to configuration line and just, you can go to, see the configuration MU. You can run that again, just go to view mashup and you can add your own lines and you can add your own objects. And we urge you to but make sure you create duplicates of these using the import and export. So this about covers it for here. Oh, sorry, I think my camera's just got stuck. Let me just Okay. Oh, got my wrong cameras there. Let me just get my camera back on. Okay. Okay, so that's about does it for our session, actually. I mean, we just wanted to demonstrate to you. I'm just going to come back to my screen. Where's my Google? And you can feel free to have a look through both monitoring, MU, and all. You know, you can make a copy of this and edit it if you want to create your own. So you can just duplicate it and then just you'd have to you've got all the functions. So this is where all the functions are linked to, like from the configuration thing, configuration helper, and configuration helper, like I said, reroutes to the selected thing and dynamically gets the charts according to. So each of the charts has a different value that's going on there. So all the objects, like you can create your own complex mashups that pull data from different places. So there's an extra lesson that you can learn from here about how to create your own mashups. I'm going to stop sharing now. So that's about it for our session. So we've shown you how SPC Accelerator works, and how you can use it to run your own SPC processes with ThingWorx things. Anything can be used with that. We've used something that's set with values. As long as it has values and it can be configured, as long as it's a thing, there's no prerequisite for a thing to be used. So you can create your own thing with some property that you are simulating, and you can run it through the SPC Accelerator to get your values. Just make sure it will dynamically create things on its own, but all that is taken care of by the solution itself. So this is a good example of how ThingWorx solutions can dynamically create things for use under the hood. So that's about it. So feel free to contact us with any details. Our next workshop is going to be in the new year. Obviously, we are going to also take a break for the holidays, for the Christmas holidays, because everyone's going to be busy. But we will be back in the new year. In January itself, we are planning our next workshop, and of course, we will be planning a different topic. So do keep an eye out, and and I hope to catch you then. So from me, Nikhil, that's bye, and definitely feel free to send your messages across. And I'm just quickly checking chat. Okay, nothing new there, but feel free to use ThingWorx, the online host as well, if you want to play around with not just today's content, but even the past content, if you want to. This is normally like enterprise level software that is only available through license, but we have been given this sandbox to use for academic purposes by PTC and Etisalat. So you have access to that as an attendee of one of our workshops throughout, and you can try using analytics to copy where to go with the previous workshop, and you can definitely do a lot more. So that's about it for the session. Thank you very much for attending, and we'll see you in 2022. Have a great day and have a good one.